the next thing I want to do, when you do this, there's a couple different ways kind of to approach it. Okay, the first way is to use your calculator and just see what this represents. Okay, so if you're looking again kind of at this unit circle as a reference, okay, our sine is a -5/9. So the sine corresponds to our y coordinate. So we know it's going to be down here, right? Just over halfway. So we have two different angles for which that's the case. We have this angle in quadrant 4 and this angle in quadrant 3. Which angle is it that we're dealing with in this problem? Tells us that the angle has to be greater than 180 but less than 270. So that means it's in quadrant 3. Okay, so we know that this is the angle that we are looking to solve for here. And we want this whole measure from here all the way to here. All right, so this is theta. This whole angle from here to here is theta. And now, in order to find that though, if we just entered this into our calculator, it's not going to give us this whole angle measure. Because our calculator for sine is only going to give us, again, if you recall, the sine is only calculated on your TI-89 in quadrants 1 and 4. So it's not going to give us this angle right here. So what we have to do is we have to use what we know about reference angles to find that whole angle measure. Okay? And so there's two ways to think of this. Okay? The first, probably the easiest way, or the way to visually see this, is if you form your reference triangle. So from the point that we extend through on our terminal side, you can form your reference triangle just by making a vertical line to the x-axis. And then you have this reference angle formed at the center, at the central angle.
Why that dotted line right there?
Because the original information said that the sine of this angle is -5/9. So this represents a y value of -5/9. And so you know that there's two different angles that are going to have that y value. An angle here in quadrant 4 and an angle here in quadrant 3. So which angle is it that we wanted to solve for? In 3. And so that's what I used to represent that. Okay, so when you look at this, if you were to use this reference triangle right here, you have this sine ratio of theta is equal to -5/9. What that means is we can actually solve for theta by taking the inverse trig ratio. So the inverse sine of this ratio, -5/9. And let's see what happens with our calculator when we calculate that. So since we're in degrees here, I'm going to make sure my calculator is turned to degree mode. And I'm going to take the inverse sine of this ratio. So hit green diamond, y, inverse sine of -5/9. Close that off. I do want it in decimal form, so I'm going to hit the green diamond button. And I get my angle measure. My angle measure is -33.75 degrees. Okay, so what that means is the angle that has this same y value right here, this angle, is -33.75 degrees. Okay, well, that happens to be equal to this same reference angle that we're using right here. So instead of using the direction of this, if we think of this reference angle is also going to equal, here the reference angle is just the absolute value of this measure. So really we're looking at 33.75 degrees as our reference angle. I can then use that to find my whole measure, because when I look at this whole measure is going to equal this portion right here plus an additional measure. Well, what was this first portion? It's equal to 180 degrees, right, from here to 180 degrees, and then we're going to add this reference angle to it. So our reference angle was the 33.75. And so if we add these two together, so if I take 180 and add this measure here. Again, in absolute values, if you want to think of it that way, or just the fact that it's the reference angle. And that gives the total value of 213.75 degrees. Now, does that measure fit the conditions that it told you here between 180 and 270? Yeah.